I am Tal Beery. I'm executive director of the Wright-Ingraham Institute, and we bring together scientists, artists, and community members to tackle entrenched land and water challenges. By mixing science, design, and local knowledge, we spark new ideas, create hands-on learning experiences that support the next generation of leaders who can work across differences, and we build strong networks for lasting change. Events like today's webinar are part of how we learn and grow as an institute. By engaging with leading thinkers and practitioners, we're not only sharing their insights with you, we're also staying current with the best practices and emerging ideas that make interdisciplinary collaboration possible. So this kind of learning is essential to our work and to the networks we help build. And this event is part of Climate Week NYC and part of our way of contributing to that broader conversation. So we're very grateful you've chosen to spend this time with us, and I'm looking forward to the discussion today, which will explore the challenges and possibilities of interdisciplinary environmental work through the lens of soil. Uh, you'll likely hear from our speakers today why soil health is such a vital and urgent topic. That land health is important is, of course, something we all recognize, but our recent work at the Institute really underscores how interconnected this issue is. Looking at the dust on snow phenomenon in the San Juan River Basin and regenerative agricultural practices in the southern San Luis Valley, it's clear that soil health isn't just a scientific concern, it's also economic, it's cultural, institutional, it's even a design challenge. And so addressing it will require successfully weaving together these diverse forms of knowledge to find durable paths forward that improve soil health and help to build resilient communities in the face of rapid environmental changes that are already underway. So I want to thank our board of directors and our strategic advisors for their incredible support in steering this wonderful organization. We have a bunch of new programs currently in development. We have many irons in the fire. So if you're not getting our newsletter, please let us know and we can share the link to sign up. Keep an eye out for a major announcement coming soon where we will be opening applications for our 2026 field workshop. The field workshop is an advanced fellowship for graduate students and emerging professionals. This one is going to follow the Rio Grande through the San Luis Valley in northern New Mexico, focusing on designing for adaptation at a time of prolonged drought. It's all about supporting the next generation of leaders who can spearhead integrated approaches to today's most complex land and water challenges. And because access is so important to us, we will also be launching a fundraising campaign towards the end of this year to make sure that this fellowship is fully accessible to all, regardless of financial need. And we'd love your support to make this a big success. So just a little bit of housekeeping. Please keep yourselves muted, but if you like, feel free to put questions in the chat as they arise. And Dylan Gauthier, who I'll introduce in a moment, will work through those at the Q&A. So with that, it is my pleasure to introduce my colleague, Dylan Gauthier, who is the Institute's Director of Research. He's going to frame today's topic and introduce our speakers. Dylan, take it away.
Yes, hello. Good to see everyone. Thanks for joining us for this NYC Climate Week lunchtime webinar on thinking through soil with our two fantastic thinkers and makers, Seth Denizen and Brooke Singer. I am Dylan Gauthier, my pronouns are he, him, and I'm the Director of Research for the Wright-Ingraham Institute. We're really excited to have the next hour to spend exploring Seth's book together and engaging with ways that soil, something that we may take for granted or think of as dirt under our feet, is a living archive, a climate actor, and even a site of political and cultural possibility. We'll also be delving into how interdisciplinary approaches to environmental problems can help us think through plausible and compelling environmental futures. This work is, as Tal was underlying earlier, at the core of our mission here at the Institute. So first today, we are going to hear from Seth Denizen, who is a researcher and design practitioner whose work spans landscape architecture, soil science, and geography. He's currently an assistant professor at the Sam Fox School of Design and Visual Arts at Washington University in St. Louis, and his book, Thinking Through Soil, co-authored with Montserrat Bonvehi Rosich and published by Harvard University Press this year, critically analyzes and unpacks the systems within the wastewater-based agricultural system in Mexico's Mezquital Valley. So this book opened up so many portals for me, and I was really excited to read it. As I was saying to Seth earlier, just everything in it, from images to graphs and charts. And also, I don't think I'd ever put wastewater and agriculture together in a sentence before. So Seth's talk today will help us think through and about soil in ways that challenge and expand on how we understand climate, agriculture, infrastructure, and politics. Seth is going to talk for about 35 minutes, 35 minutes, and then we'll be joined for a response to the talk by Brooke Singer, who is an artist, an organizer, and a professor of new media at SUNY Purchase here in New York. Brooke has been working with soil for over a dozen years, co-founding the La Casita Verde Community Garden in Williamsburg, Brooklyn in 2013, and launching her ambitious soil research project Carbon Sponge at the New York Hall of Science more recently, through which she continues to collaborate with soil scientists, farmers, and artists to explore carbon farming. And so Seth and Brooke, thank you both for being here today. And for everyone, please join me in first welcoming Seth Denizen.
Hi, everybody. Really appreciate your time today during your lunch hour, to come to this talk. And also thanks so much to the Wright-Ingraham Institute for hosting this event. It's really great to be in conversation with you all. So I'm going to be talking through what I think about as thinking through soil. It's a concept that's based in a kind of extended case study of the Mezquital Valley. And I'm going to be kind of taking you through that case study, but also hopefully showing you what I think are the kind of broader implications of the book as a case study. The first thing that I wanted to do is just start by saying that this work comes out of a kind of engagement with soil that goes back a while for me. I first started studying soil in a really traditional way with this person here, Randy Southard at UC Davis. And part of my time kind of being exposed to the kind of incredible and invisible world of soils took me through this kind of deep engagement with soil taxonomy and the process of sort of understanding and classifying soils. And, you know, it's important if you've never seen the kind of diversity of soil that exists. I think many of us are familiar with the kind of landscapes that we see around us, the immense diversity of landscapes, but we don't always understand the relationship between those landscapes and the soil below. And the way in which those two things are sort of related and important to one another, and the way in which kind of geomorphology and climate and vegetation shape the landscape in really important and crucial ways, and in ways that also produce just an enormous diversity of soil conditions. You know, of course, when you go up in altitude, you find soils that are younger because they haven't been weathered as much, because they haven't been exposed to as much water. There's a kind of aridity to cold environments. So you see sort of very young or not very weathered soils in cold environments. In warm and hot environments, you see weathering that can have shaped the soil for hundreds of thousands of years, and sort of unpacking the story of soil formation can really take you back in geological time. There's just a ton of different kinds of soils and soil relationships around us. And it was this kind of engagement with these different soils and these different landscapes that I think really started to shape thinking through soil in important ways. And, you know, one of the kind of, I think, most important ways that it did this was for thinking about the relationship between soils and vegetation. So in this particular soil that you see here, soil scientists call this time transgressive coastal dune. And it's time transgressive because it has these sort of deep-rooted grasses and rodents which continuously mix organic matter into this windborne material, sort of turning this very young soil into that they call an inceptisol into what's now called a humusteppe, which is, you know, also this kind of way of thinking about the biological processes of life also affecting soil structure in fundamental levels. And I think for me, probably the most important soil that I ever studied was this one. And this is the one that I would say is really sort of the core of the thinking that led to thinking through soil, which is this, what you're seeing here is the Mendocino pygmy forest. And it's just a kilometer away from the soil that I just showed you. It's incredibly acidic. So some of the soil horizons you see there on the left, or sorry, on the right, are have a pH as low as like 4. The forest that you see is this kind of very, very stunted and small forest of Bolander pine. And what really fascinated me about this particular place was that there's this story that I was told about it, which is that the famous soil scientist Hans Jenny came to this particular forest with his students and would tell this story, which is that um, in the Mendocino pygmy forest, when soil scientists would take their students here, they would kind of all gather around the soil and say, this soil that you're seeing here is incredibly acidic because the ericaceous plants are continuously dropping their acidic leaves onto the ground and making the soil really acidic. Whereas when the sort of botanists and biologists would take their students to the Mendocino pygmy forest, they would all talk to their students and they would say, wow, so this you see how the forest is so small and so stunted? That's because the soil is incredibly acidic. So Yenny tells this story to kind of remind us that anytime we tell sort of ecological or environmental stories with sort of linear causal arrows where one thing causes something else, often what we miss is the reciprocal relationship in which one thing is causing the other. So the acidic soils are creating conditions in which ericaceous plants are thriving. The ericaceous plants are dropping leaves, which is acidifying the soil, making the soil even more acidic, right? So there's a way of kind of reciprocally forming each other. And I think that, we were talking about sort of interdisciplinarity in this talk. I mean, I think if there's any historians in the audience, you would probably be really sympathetic to this point because, historians also need to be very sensitive about the kind of ways in which they narrate causality in historical accounts. It's not always as simple as one thing causes another. Things are happening together. Things are forming in ways that don't conform to sort of linear causal chains. So there's this kind of, I think, sensitivity towards thinking about systems as a process of co-formation that I was really fascinated by. And that kind of took me into this research where I started to ask the question of how would this thinking change our ability to narrate human environmental systems? And that's when I started to really get interested in this system that you see here. So this is Mexico City in the Mezquital Valley. And if we just kind of look closely here, basically what's going on is that you can see the sort of present day municipal boundary of Mexico City in the bottom. And then that kind of small black dot in the middle of that boundary in 1910 is the size of Mexico City in 1910. And it was right around this time that Mexico City started sending all of its wastewater to the Mezquital Valley, which is this part in the top of the image, in order to, well, at first it was in order to just get rid of the sewage, but people in the Mezquital Valley started farming this wastewater almost immediately. And as the city grows, what you see is that both the city and the Mezquital Valley start to grow reciprocally. So the kind of agricultural area that's being irrigated increases as the city grows. And of course, as you all probably know, the growth of Mexico City was more than exponential. It's basically around 25 million people, depending on how you count the kind of ever expanding urban periphery. And also what you can see here is that the connections between these two areas are also growing. So the number of pipes that connect Mexico City to the Mezquital Valley are also increasing. This is the size of one of those pipes. They're absolutely enormous. And they've been taking Mexico City's wastewater to the Mezquital Valley in sort of ever increasing quantities over the course of the 20th century. And today they call the system the drenaje profundo, which is the sort of deep drainage of Mexico City. And so the question becomes, what kind of soil forms in this kind of reciprocal relationship with the metabolic and material byproducts of a city of 25 million people? What kind of conditions does that produce? And also, I would say, in some sense, how is the city been reciprocally formed by this soil that it produces? So that's the kind of question that I'm going to sort of take you through today. And as I said, this is a kind of a case study. So I'm going to need to go into some particulars to this place. I think it's actually quite important when we talk about environmental conflict, environmental crisis, to be specific about the places that we're talking about. But I'm also going to, I think at the end, try to share what I think are some sort of general points that we should be thinking about, that we should take away from this case study. So really kind of the specific conditions that are produced here come from this relationship that you see in this map. So if you're not familiar, this is Mexico City. We're looking right now at the topographic boundary of the basin of Mexico, which you can sort of see here as this dotted line. And so the function of those pipes that I was just showing you is both to drain the city's floodwaters in the rainy season and also to evacuate its untreated sewage to the Mezquital Valley, where it's used for agriculture. And this is, basically how the system has worked for over a century, operating as the world's largest and longest running wastewater agriculture system until the early 2000s, when the Mexican government decided to repay what it called its, quote unquote, historic debt to the Mezquital Valley and build Latin America's largest wastewater treatment plant at the end of these pipes, called the Atotonilco wastewater treatment plant, shown here on the map. But the project has run into some unexpected resistance. And this kind of conflict is what I want to sort of describe to you, because I also don't think that this conflict is really understandable outside of this context of soil. So if we kind of zoom into November 2018, which is pretty recent, this is when I would say several thousand farmers essentially marched on Atotonilco, right in front of its sort of freshly painted entrance, because it had only been opened in 2017. And they formed this barricade at the entrance and sort of began reading a list of demands. And the demands are probably not what you're expecting. So for instance, the demand was not to place the treatment plant somewhere else, like on the Mexico City side of the pipe, which would have been logical. Instead, their demand was actually just that the treatment plant stop treating water entirely. So like not here in the Mezquital and not anywhere. And opposing treated water in a region that suffers from wastewater pathogens and enteric disease is an argument that I think we can agree doesn't really lend itself to sound bites. It's kind of a weird position to take. And it also, I think, came at a really bad time for the farmers, because the protest also happened in the middle of the Mexican fuel crisis. And so confusingly for the media, the farmers were also accusing the government of theft. But this particular theft didn't consist of missing fuel from pipelines, but rather missing organic matter from Mexico City's wastewater. So to the media, the kind of euphemism of aguas negras or black water didn't really obscure the kind of black humor of the underlying accusation that the government was stealing the people's shit. And as a news story, it was almost a kind of perfect parody of the fuel crisis. So instead of stealing the most valuable resource in the nation with incredible cunning, they were stealing the most valueless by means of an enormously expensive and complex machine, which you see here, called a Atotonilco. So this is essentially the sort of political impasse that the region finds itself in today. The government sees itself as having repaid a historic debt to the Mezquital Valley by cleaning it up after a century of neglect. But the farmers see a different kind of debt entirely. For the farmers, the federal government is effectively converting the government's historical debt into financial debt for the farmers by forcing them to buy fertilizer that used to come in the wastewater for free. So in short, the wastewater offered a significant subsidy, and now the farmers feel like they're being impoverished in the name of public health. Rather than feel grateful for the government's repayment of their perceived historic debt, the farmers really feel silenced and patronized by what they see as a reductive concept of what health should look like in their community. Reductive because it prioritizes addressing certain kinds of toxicity. We might call them charismatic pathogens that produce acute illness over others like heavy metals, industrial chemicals, air pollution, and farm debt that are more likely to produce chronic conditions. Because after $1 billion spent on the treatment plant, Atotonilco can't really remove the heavy metals. And I'm going to say more about this later. But first, we need to understand a kind of another crucial dimension of this story of kind of contested entanglements, which is that this is not actually the first time that farmers in the Mezquital have found their bodies, their agricultural practices, and their form of life an object of medical concern. In 1976, the Mexican filmmaker Paul Leduc made a documentary called Etnocidio, Nota sobre el Mezquital. And that film opens sort of dramatically with this funeral of a child, a sort of slow procession winds up this arid mountainside of cactus and agave as a man sort of balances this small white casket on his shoulder. And in the film, we never really learn how this child died. But later, the film will tell us that 70% of child mortality in the Mezquital Valley is due to communicable diseases like tuberculosis, and that there's less than one doctor per 3,000 inhabitants at the time the film was made. And as a portrait of the Mezquital Valley, Leduc's film really is a kind of catalog of scenes of immiseration, bridged by these really tense interviews with the valley's Otomi, or Ñañu indigenous group. And in 1976, the Mezquital was, not only a famously poor region of Mexico, but probably the most famous poor region of Mexico. And the Otomi were a symbol of its extremes, defining for most urban Mexicans the limit of what was imaginable as rural poverty. And starting in the 1930s, the Otomi of the Mezquital Valley became primary research subjects for famous anthropologists like Manuel Gamio and a succession of sort of presidential administrations who wanted to solve what every government in the Americas had taken to calling the quote-unquote Indian problem. And during this time, the Otomi were subjected to really every conceivable kind of biological and cultural test. And of course, at this time, there was very little distinction between the biological and the cultural. A delegation of French and Mexican eugenicists measured their basal metabolic rate to make claims about indigenous lethargy and stupidity. In the study you see here from 1961, the faces of indigenous people were studied as biological expressions of inner psychological defects, revealing sadness, distrust, indifference, and docility as sort of typical indigenous afflictions. And at this time, the kind of Indian problem simply expressed was a fear that modern economic development was incompatible with indigenous forms of life. And this made indigenous people a drag on the national progress, also the GDP. The solution, therefore, was really to just foreclose these forms of life through economic and cultural assimilation. And many of the tactics for incentivizing this assimilation were documented by Leduc and Bartra and Ethnocidia in the 1970s, like this Center of Social Integration that you see here. But for the influential anthropologist and government advisor Manuel Gamio, who I mentioned before, really this is the most important thing. The kind of primary tool for transforming the Mezquital Valley was irrigation. Irrigation would essentially change indigenous diets from primitive corn to energy-rich soybeans. It was the solution to their famously poor hygiene, which of course the anthropologists had made the Otomi famous for since the 1930s. They started reporting that the Otomi don't take baths, and because there isn't enough water. And it was also the solution to their diseases, which were a result of their faith in shamans and healers, in the anthropologists' view. It would also kind of teach them Spanish when they brought their goods to market. So in short, irrigation was really, in this view, the sort of the beginning and the end of the Indian problem for Manuel Gamio and anthropologists like him, who also believed, contrary to many of his sort of eugenicist colleagues, that it had the power to racially convert indigenous people into Creoles. And today, when we look at this kind of majestic Endo reservoir, which is fed by the Drenaje Profundo of Mexico City, and acts as the world's largest lake of sewage, maintaining the correct timing and volume of wastewater for the Mezquital Valley's irrigation system, it's really easy to forget that this reservoir was built to solve the indigenous problem, or the kind of the Indian problem, as I mentioned it before, to quote, irrigate the indigenous zone of the Mezquital Valley, end quote. And this history forms the basis of what I would call a kind of biopolitical amnesia in the Mezquital Valley. There appears to be no memory among government water managers that irrigation canals were supposed to be the solution to the problem of health and hygiene in the Mezquital Valley, rather than the cause of all their problems. Irrigation arrived in the 1950s waving the flag of public health on behalf of indigenous people. And then suddenly in 2014, it's basically public health that's horrified by irrigation. And while Otomi farmers in the Mezquital have always been subject to state-imposed necropolitical violence, that of course pathologizes their form of life as dirty and primitive, the strange fact is that the definition of dirt keeps changing. So what was clean in 1952 is dirty today. So if we look again at the Mezquital Valley, here you can see a kind of historical timeline of wastewater irrigation. The darker areas in this map are essentially the older parts, the parts of the valley that have been irrigated for longer. The lighter areas are more recent. And I think part of what we need to see in this map is soil formation. And crucially, I think we need to start seeing the soil not just as a pile of objects like sand, silt, or clay, but as a material that's formed through human social relations and non-human biogeological processes, both which contribute to a kind of soil that is really an emergent property of these relations. And crucially, what this conflict that I'm trying to describe to you here is really about, I think, is what kinds of social relations will continue to form and be formed by this agricultural system. And I think that's the sort of core disagreement between farmers and the government. So let me show you a little bit more explicitly what I mean by this idea that the soil contains social relations. So in our book, what we've done is we've tried to visualize this alternative conception of what soil is through the language of drawing. And what you're looking at here is essentially the soil of the Mezquital Valley as we see it today. And like basically each of the sort of smaller drawings that make up the profile are what we call in the book soil characters. And these characters don't refer to a kind of physical object, but rather to a material relationship that shapes the soil's formation in some material way. And in this sense, we can think of this soil profile that you see here as a kind of another way of generating a cartography of the valley's processes of soil formation. And in the time that we have remaining here today, I can't really tell you everything there is to see in this profile. For that, you'll have to consult the book. But I do want to sort of give you a sense of it by showing you 3 soil characters that shape the properties of the soil in the Mezquital Valley in ways that I think are important today. So the first thing that I want to show you are the heavy metals. the paradox of the soil in the Mezquital Valley is that the same wastewater that brings heavy metals also brings the organic matter that binds heavy metals, keeping them from being bioavailable. So the treatment plant can't sort of remove the metals, but by removing the organic matter or reducing the organic matter, it can actually reduce the capacity of the soil to bind legacy metals that have accumulated in the soil for over a century. The second thing I want to show you is the antibiotics, which also still get through the treatment plant, and both in the wastewater and also in the treatment sludge that the plant produces. And as you may know, antibiotics were essentially invented by soil bacteria. So when you put them back in the soil at low levels, you create the kind of perfect environment for the evolution of more antibiotic resistance. And that's really what we see today, very high levels of multi-drug resistant bacteria in the soils of the Mezquital Valley. And finally, the third kind of aspect of this soil that I want to point out is that the valley's relationship to corn has also been shifted by the social relations created by the North American Free Trade Agreement, or NAFTA. So the traditional dryland conical maize cultivated by Otomi farmers for centuries has been replaced by a larger variety of hybrid corn that requires irrigation and high nitrogen inputs. And at the same time, the most pharmaceutically active compound by weight in the soil of the Mezquital Valley is a drug called metformin, which is a diabetes medication. Today, Mexico has the highest incidence of both diabetes and obesity in the 36 member countries of the OECD. And by 2050, the lifetime risk of diabetes for all Mexicans will be somewhere between 1 in 3 people and 1 in 2 people. And from my research, it seems that the deeper origins of this rise of diabetes in Mexico may actually have a lot to do with NAFTA, as this trade agreement made corn cheaper to import from the US after the agreement was signed in 1994, hurting small-scale agricultural producers in Mexico that relied on this crop for income. But it also made corn syrup-based soft drinks less expensive than bottled water. And this agricultural policy then contributed to the largest average per capita intake of soft drinks in the world, which is actually comes in at 163 liters per year per person in Mexico. So what we see in the soil of the Mezquital Valley is, hybrid corn being irrigated with diabetes medication, which I think offers, the kind of clearest possible sign that something has gone deeply wrong with our food system. And I also want to mention that Tontonilco, as the wastewater treatment plant, will change none of these things. So the question that we're really left with is the following one: if the city is producing the soil through its wastewater, and the soil is reciprocally producing the city through the food that it grows and the sort of economy that it generates, then I think we have to ask, who do we want to become in partnership with this agroecological system? So, to use the metaphor that I began with, what kind of forest, right, in the Mendocino does this system make? And from a practical perspective, what we want to point out is that the political impasse in this region in central Mexico really can't be understood apart from this question. The conflict is essentially over 2 alternative environmental futures, which will be realized through 2 alternative soils, which contain 2 alternative sets of social relations. So the conflict over which of these social relations, the conflict is essentially over which of these social relations we want to have. And I think the kind of larger question that we could also ask is, what would it mean for Mexico City to think of itself in this reciprocal way with the Mezquital Valley? So what if the soil became a new kind of criteria for how we imagined cities? What if instead of talking about wastewater agriculture, we started talking about wastewater urbanism? What would we do differently? How would the city be different or differently entangled with its agricultural periphery? Could we imagine a city that sent less heavy metals in its wastewater to the Mezquital? Could we imagine soil-safe antibiotics? These are a lot of the questions that we're kind of grappling with and wrestling with in the book. And we hope that the book is a kind of open invitation for you to try to think with us about these kinds of questions. So with that, I'll just conclude. And this is the kind of give you a brief sense of how the book is organized and how it's laid out. And yeah, I hope that I really look forward to hearing Brooke's comment.
Thank you so much, Seth, for sharing some of the fascinating insights from your research in this book. And yeah, the book is Thinking Through Soil. To respond, initially, Brooke Singer is going to offer some reflections on Seth's talk and share some connections to her own work. Brooke, the Zoom room is yours. Go ahead.
Great, thank you. Let me get my slides up. There we go. All right.
Thank you.
Well, thanks to Dylan and Tal for inviting me to do this response and for introducing me to Seth and Montserrat's work. It's really phenomenal, super, super exciting. And I'm not just saying that. I was so thrilled to read through this book over the last couple of weeks. It does something that no soil book that I know of does, which is it's beautiful. It uses imagery, illustration, photo documentation to its fullest. It's interdisciplinary from the humanities to soil science, from the arts and design to kind of more philosophical questions. And it's really quite remarkable, and I'm thrilled to share some of my thoughts. And what I thought I would do is connect, the book is a deep dive in this case study, but it also gives this kind of broader framework that I think is super useful, or it has been for me in terms of making connections to the work I've been doing over the last decade or so. And so that's what I'm going to do is just tease out a few parts in just about 10 minutes to show how this framework I think is quite useful and exciting and intellectually stimulating with tons of future possibilities. So just like a context of who I am and where I'm coming from, Seth and I share a background in fine arts. Mine is a visual art photography background that developed in the last couple of decades into more of an interdisciplinary research-based arts practice. So it's highly collaborative and participatory. And it was about now, I guess 15 years ago, the image in the kind of center right of the two people standing in front of a cart, I was in a collaboration in Madrid with 3 other artists, and we designed a way to divert edible food that was heading to the garbage into people's hands. And so that was like my introduction to waste and kind of problems of the food system in urban areas in particular, and composting. So when I returned back to Brooklyn, I co-founded this garden, La Casita Verde, that is still going strong in South Williamsburg, Brooklyn. And then eventually kind of devised this project Carbon Sponge, which is a collaboration with soil scientists, other artists, land stewards, educators. And it started the New York Hall of Science, like Dylan mentioned, and more recently moved kind of the hub, the center of it, upstate to the Hudson Valley. And it's interesting for me to think about the Hudson Valley in relationship to New York City, in terms of Mexico City and Mezquital Valley that Seth has been talking about too, and there's some interesting correlations there. So soil identity is super interesting and something I've been fixated on and is really going through somewhat of a paradigm shift, and Seth's book discusses this. Soil has been for a long time not thought of at all, or if it's thought about, it's more in terms of dirt, that thing under our feet. But we know today it's quite alive, it's highly diverse. Something like over 50% of Earth species are soil bound. So that's quite incredible. And with new discoveries and technological kind of apparatus to look into that black box. The underground is still very much a black box of unknown, but with DNA sequencing and kind of radar systems, there's a lot that can be learned without penetrating the soil aggressively and at times digging it up and looking at it directly. And I think, there's this kind of cliche at this point. Leonardo da Vinci said we know more about the heavens than we do about the soil under our feet. I think that's still quite true. And one way of thinking of it too is we have a lot more stories in science fiction that talk about outer space exploration than we do about inner space soil exploration. So in the book, the authors write, the identity of soil in the Mezquital Valley is largely a matter of perspective. For farmers, it's the organic matter that gives the soil its fundamental identity. For the government, it's pathogens, and for soil taxonomy, it's neither of these. Oops, did I just stop that? I'm sorry. So this is really underscoring the complexity or the soil matrix, what Bruno Latour talks about as the critical zone, the shift of thinking about how this kind of looking through the kind of object through a prism and all the different parts, which you could think about as the soil characters from the book. And this is directly kind of what is in opposition to the classification or soil taxonomy that's coming out of the Victorian era. So the late, 19th century and into like kind of codified in the 1950s. And this is a geological framework. So soil is separated and it's often, it's visible. You can see the color shifts. You can feel the texture changes. But these horizons or layers are demarcated. And it's an attribute of the climate, parent material or the rocks, typography, organisms, and time. And so that's what distinguishes one layer or horizon from the other, and none have to do with humans except maybe the topmost layer, the organic layer or the O horizon. So if you see something like this, like I did on the side of a dune in Northern California, it's pretty easy to imagine its depiction in kind of geological terms. And this is a beautiful map by Ora White-Hitchcock from the kind of mid-19th century that she painted for her husband, Professor Hitchcock at Amherst. And then if you have the chance, like I have, of being inside a soil pit and working with soil scientists to devise these classifications and make up a profile of a specific place, it is a pleasurable experience. It's amazing to be inside the ground. It's electric. Maybe it's the microbe kind of electromagnetic force that you feel, but it's cool. It smells. The perspective from being 6 feet underground and looking up into the world is quite, I think, awesome. And but it really is frustrating, or it was frustrating for me to like sit there with these Gulf teas and mark out the lines and to kind of think about these separate spaces when all of the action and the things that seem to like be the driving force of the soil and life was happening in these areas, in the liminal spaces between things rather than separate. So that got me thinking about what would a site profile look like if you merged the parts from above ground, below ground, and began making these flags in 2017 and thinking about parts of the ecosystem that could be related into what would be a bioregional flag rather than a geopolitical flag. And then back to the book, this quote, "Soil challenges us to think about agency as something that always dependent on some other agency for its capacity to act. In other words, there are no heroes in the soil. Everything depends on something else. It emerges in the space between actors in the process of acting." So exactly this kind of synergy of forces, the co-formation that Seth was talking about earlier. And another kind of this critical zone, to go back to Bruno Latour, this is another late in his life, kind of his last project before he died recently, was visualizing the space, this very thin layer, the skin around the earth, and thinking of it as a possibility for a way to visualize, us being what it means to be on Earth, us being on the inside rather being on the outside. So this would be a visualization of our earthly boundness, so to speak, that is kind of in direct relationship or direct opposition to the blue marble. So being out in outer space and looking down and kind of having this unified whole of the earth, thinking about being inside out and where the human position, is it the God's eye view or is it inside the earth? So from this text, the critical zone text, "So today, much as in other earth-shaking periods, we need aesthetics defined as what renders one sensitive to the existence of other ways of life. Just as politicians are supposed to hear voices previously unheard and scientists to become attuned to phenomena so far invisible, artists are challenged to render us sensitive to the shape of things to come." So the kind of role of representation, the role of aesthetics, the role of the artist in all of this, Bruno Latour champions in a way that I can get behind. So symbiosis, this leads us to the question of what is happening at those sites of exchange. If it's about this kind of confluence, these things acting upon each other in reciprocal ways, what is this, and where can we find kind of models for this? And for me, this unfolds where science kind of unfolds as fiction, not in the sense that it's not truth, although as we know, science is as factual as we can be in the moment, is quite contingent, but kind of fiction in terms of the storytelling to bring us into the action, and to make it something that we want to share and are excited about and consider as being part of. So we have these the soil character of the Esquimales, the ants, which are nitrogen fixing, and very important in the life and the thriving of the maque plant that Seth speaks about in the book, as well as the milpa or the three sisters, and the synergistic of mutualism of the corn needing nitrogen, receiving it from the bean through the legume. The legume is climbing up the corn. It's acting as its scaffolding with the squash, also taking part in terms of covering the soil to reduce heat and keep in moisture, and being shaded also by the maize, the corn. In Carbon Sponge, this project I mentioned earlier, we've been thinking about the symbiosis and sharing the story through the rhizobia, which are bacteria in those root nodules. So they glow pink when there is nitrogen fixing. So the atmospheric nitrogen is fixed by these rhizobia in these nodules, and then the plant is able to take up that form of nitrogen, which we know plants need nitrogen to grow. So it's this gorgeous kind of cycling, acting upon, the plant is protecting the rhizobia in that nodule, forming that nodule around the bacteria, and the bacteria giving the nitrogen to the plant. And this kind of site was really just fascinating to me, and I really wanted to know more and more about what was happening. And there is kind of recent evidence. This is Dr. James White's research at Rutgers. This is not rhizobia exactly in these nodules, but there is information, discovery about rhizophagy, or the way that roots will uptake free-floating bacteria fixing nitrogen, nitrogen fixing bacteria into the root tip and spin it around, oxidate it, strip the bacteria, suck up the nitrogen, and then spit the bacteria out the root tip where they go back into the soil, regenerate, regrow outer skin, fix more nitrogen, and go through this cycle all over again. So this is where the fiction, the narrative, the story becomes really fascinating to me. And it's a bit kind of mind-boggling discoveries that are happening right now in soil science about these tiniest of creatures that our lives depend on, and the life of the plant as well. So one last touch point is the technosols, urban soils, which is obviously a big part of Seth's book, and has been a focus for my work at the New York Hall of Science starting in 2018. And so technosols, from the book, we seek to produce descriptions of soil that acknowledge the full range of human and non-human desire that participates in the process of the soil's formation. And for ethical reasons, we want to produce this portrait of the emergence of the soil identity in a way that is inseparable from its unrealized possibility and potential future. And I love this because, first of all, it's acknowledging that for about 20 years now, soil scientists have been classifying technosols, or human engineered soils, as another soil type in the World Reference Database. And those are soils that are created by human activity. Soils are moved around a lot, they're mixed together. And as Seth's book points out and kind of describes at length, they're artifacts, they're human, they're remnants of human origin, whether it's chemicals or, junk that's like dumped, that really have this profound influence on the chemical, physical, and biological properties of our soil. So knowing this, what can we do differently, or what can we propose of actors on the soil formation? And here's a picture of carbon sponge. So in 2018, collaborating with soil scientists from CUNY Graduate Center, other artists and educators, we designed this study, which was both a museum exhibition to talk about carbon storage and technosols, and also a kind of professional scientific experiment to look at a mix of soil. So here's the technosol. We were mixing on the left sediment from a construction site in Queens with New York City made compost. And that was our grow medium. And we changed what we grew across the beds. And we had some bare beds, which were our control, to look at the kind of nutrient cycling and carbon buildup and the plant health across a period of 2 years. And when you think about these two sources, these two sources, the sediment and the compost, which made our soil, our technosol, they're from very different time periods. The sediment is from 20,000 years ago. It's 50 feet deep in the ground. Was formed 20,000 years ago by glaciers in the New York State, in Queens. And it would have been trucked to landfill years before, even like a year before. This was a new program called the Pure Soil Bank run by the mayor's office in New York City. So changing its character from a waste to something that part of a circular economy, it becomes a foundation for new growth. But 20,000 years ago, with compost, which we all know takes a couple of years in a municipal system to form, and also because the sediment had zero carbon and we knew how much compost we were adding and what the carbon content of that compost was, we could really accurately gauge the increase of carbon in the soil to think about carbon farming and what it means to be an urban carbon farmer. So here's a couple of my collaborators in the garden measuring plant height and growth during the study, the research in the laboratory, and just the resulting scientific paper, the peer-reviewed journal Geoderma, where we published our findings that yes, in fact, technosols can or do cycle nutrients similar to native soils, rural soils that we've been talking about and classifying for 100 years or so. and what the potential of that now is kind of the next step of this project. And then just to end here, knowing, again, like what it could mean as a human in the system, to take kind of more protracted or kind of considered view of what it means to be an influence in soil formation and where we want that to go, right? Instead of like thinking about what are the consequences of these actions that we never even thought about or took into consideration or think of as externalities. What do we want our relationship to be? What are the plant partnerships? We understand and we know quite well what we want to get out of it. What is the plant getting out of it? What is the soil getting out of it? What is the microbes, the macrofauna, and so forth? So on the left, the beautiful Maguey plant, Seth and Montserrat describes some of the kind of powers or the benefits of this plant. It's resilient, it efficiently photosynthesizes, it's food, it's alcohol, it's building materials, textiles, guardian of soil, so forth. And the sorghum, which I've been growing as part of the Carbon Sponge Hub upstate, is very similar in terms of climate-resistant plant, a photosynthesizer in the C4 category, so also very efficient. It's food, it's drink. You can make building materials or paper out of it. Biodiesel, it's an accelerator of soil carbon. And those are the human kind of benefits. Then ending with the question of what are the plant benefits? What did the plants need from us? What does the soil need for us? Who are the other players that we're in partnership with?
This has been wonderful. Thank you so much, Brooke, for that thoughtful and generative response. And at this point, we do want to open things up to conversation. I can start with a few questions for Seth and Brooke, and then we'll invite your questions from the audience. Feel free to put them in the chat, or if you want to unmute yourself in a minute, we can do that. And I think we should take a little bit of time to follow up and dig in here. And actually, just building off of your last point, Brooke, and tying it back to something that I think I gleaned from reading Seth's book in this kind of question of influence in soil formation. So, thinking through soil really pushes us to see soil as more than a material and asks us to rethink how we understand and categorize and taxonomize and analyze soil itself. And I think it challenges us to see soil differently and to understand ourselves differently in relation to it. And I think, if I'm not mistaken, at least in my reading, Seth, this one of the guiding frameworks is really, though it's not maybe announced, but it feels like this kind of struggle with how do we think of soil in the Anthropocene, knowing that it is composed of organic and inorganic matter, chemicals, and fossil fuel derived and waste products and other materials that maybe weren't traditionally part of these soil profiles, right? And back to, I think this was a lovely turn of phrase from Brooke from your presentation. This when you were talking about Bruno Latour and this idea of what is composed within this skin around the earth. So this question jumps to me as like both who do we want to become, and how, as we are seeing the soil and thinking the soil differently, are we also more aware in doing that of how we're shaping the soil or what we think of as soil, just across the board. And I don't know if Seth, you can jump in on that kind of open-ended question, but just getting back into some of this thinking between, how much of soil is outside of us and how much of soil is what we are making it.
Yeah, thanks for that, Dylan. I think my way of thinking that really goes back to this kind of Mendocino pygmy forest approach, which is that we are both making and are being made by these environmental systems. And I think it's probably also important to acknowledge, during New York City's Climate Week, that we kind of live right now in this age of paralysis, where we're sort of unable to address or meaningfully change our relationship to the climate and to the production of the climate. And part of that, I think I see as I kind of diagnose as a similar problem, right? We want linear causal explanations for how we can remain unchanged and change the climate. So this is like, for instance, you could think of geoengineering as a way of, if we could just, if there's something that we could do, we could fix the climate and then we wouldn't have to change. We could just go on doing the things that we normally do, but then the climate would be fixed. And that would be a kind of linear causal sequence. But the reality is that what's actually already sort of happening is that we've changed the climate, and now the climate is starting to change us. It's starting to change how we can live. It's starting to change what we do. It's starting to change how we think about our place in relationship to the world. This kind of reciprocal feedback loop in environmental systems of being produced, producing and being produced by, is I think what I would find slightly missing in the framework of the Anthropocene, in the sense that, this kind of the emphasis in the Anthropocene is always on like, well, humans have now made geology or something. We've now made this thing that is now it's not nature anymore. Well, that's kind of a cul-de-sac. I mean, I don't really know what to do with that. What I'm actually much more interested in is thinking through these kinds of reciprocal cycles of production and action, where environmental systems are being made, but then they're also remaking us. And it's only when we start to think dialectically about how these environmental systems are being produced and producing us that we can start thinking about how we might want to change that sort of cycle of production, who we might want to become, what kind of climate we would need to make in order to become the kinds of things that we want to become, right? What kinds of things that we would need to do to change about ourselves in order to not be produced in certain ways that we don't want to become. I feel like the climate is already changing me in ways that I resent. So I think that's the kind of cyclical way that I'm trying to sort of introduce into this question.
I love that answer. Brooke, do you have anything you want to add to that, or does that trigger thinking about your own work there? Yeah.
I mean, I guess I could add one thing, which is, the pressure when we're thinking about, like carbon farming or kind of a lot of these new tools, there's a pressure of continuing systems of extraction so that, moving towards, well, great, now we can quantify carbon storage, which we actually really can't. The more I've learned about, the messier it is and the more interesting it is. But then, there's a big push to whether it's carbon credits or somehow, how can this fit into economic models and drivers for progress and growth, right? And it doesn't. So then, the kind of the best answer, at least working with farmers in the Hudson Valley, is thinking about how we're growing the grain shed specifically to Hudson Valley, how we're breeding this plant specifically for Hudson Valley. And so you do get this kind of almost regressive, retroactive stance of, well, capitalism came along and transportation, the railroads, and, towns went from developing and or providing everything you needed to being like maybe the wheat producers, and another town was the shoe producers. And then there's this like kind of, the globalization effect made this mass production and individuation the norm. So when we're farming in these ways and thinking about the kind of these systems of place-based farming and soil formation, it becomes hyper-localized. And then to support that, it's just like a completely different framework that is really unsustainable economically, and farmers need to eat, and they are small businesses, right? Because they're being outcompeted by these global massive systems, and the price of our corn or sorghum is going to be so much more expensive at the local level than it is in a huge industrial farm in Iowa. So, one place I'm kind of interested now is this clash of ideas of, how this can all work practically and actually support communities, be staple food, food security, soil security, and income a lot of these are first generation farmers in the Hudson Valley and maintain farming in a place where property and land is very expensive. So I guess I'm acknowledging this kind of breadth and the spectrum from the philosophical and the ideal across the practical and where the rubber hits the road, so to speak.
Yeah, justifiably so. I think I'd like to offer to anyone in the audience who has a question, if you want to, feel free to unmute and ask a question or put it in the chat. And if not, I can ask one final question, but we'll give some space here for others who might have pressing things to chime in. Great. Oh, wonderful. Yeah. So hello. In the chat here, we have Daniel Carmelo. What has your relationship building process been like with the farmers as you worked on this project? I'm assuming this is for Brooke, but maybe it's for either of you. Maybe that's for both of you. I don't know. Daniel, do you want to qualify that?
Yes, either one. If you've had a different experience, I'm really curious about that. Thank you so much for this talk.
Thank you, Daniel.
I'll just jump in first. So it was during the pandemic, I was spending more time in the Hudson Valley, along with a lot of other New York City people, and had developed this kit and these processes at the New York Hall of Science, and just started doing farm tours, small farm tours. And by small, these are like 1 to 2 acres, sometimes 6 or 7 would be a big farm, with my collaborators, and seeing what kind of measuring and kind of regenerative or agroecological practices were happening in this region. There's a lot of knowledge, but not a lot of resources or time to cover crop or to trial climate smart, resilient plants. So it's just been word of mouth, starting to collaborate with one farmer who then has a friend on the road who's a farmer, neighboring farm, and I've now collaborated with probably over a dozen farmers in Ulster County and Columbia County, Greene County, and so forth.
Thank you, Brooke. And Seth, what was your relationship like with any farmers in the valley?
Yeah, well, what's in the Mezquital Valley, doing soil research is extremely political. So building those relationships is delicate. It's something that takes time, something that takes years. And for me as a researcher coming in from the outside, I really had to rely on years of sort of trust building that soil scientists had built up with farmers in the Mezquital Valley. And those relationships are constantly under strain, because if you measure the soil and you want to, for instance, even something as simple as measuring the organic matter in a soil, and the farmers are claiming that the wastewater treatment plant has reduced the amount of organic matter that's coming in the wastewater, if you measure the soil and you find that the organic matter hasn't gone down, well, then the farmers are like, well, why am I letting you onto my land in order to take those measurements? And also, like, maybe I don't even believe in your science. Maybe you did the test wrong. I think for me, part of this project was written during COVID. And so much of what was happening in the United States during COVID, with people saying like, wait, I don't believe what you're telling me about these vaccines. Do they work? Are they going to hurt me? Are they going to do more damage than good? I don't believe your science. Where does your science come from? Who are you citing? I have my own science that I'm citing. So much of those kinds of dramas were already playing out in the Mezquital Valley in different ways, with competing scientific claims. And of course, because we live in a world in which science has the kind of the power of expertise in our sort of in the apparatus of civil society. And so if you want to make a claim that, for instance, those apparatuses don't understand or agree with. Like, for instance, you want to make a complex claim like, hey, by the way, soil contains social relations, and the kind of soil that you're producing through your giant machine is going to make my life worse. Well, you're just illegible. Like, no one, like, that's gibberish. But if you say like, no, you are decreasing the percentage of organic matter in my farm field, and that is reducing my crop yields, and I now have less corn, well, then that is an argument that people can understand. And that does have the sort of scientific seal of approval. So, in order to do research in these areas, you really need to cultivate relationships and cultivate trust. And those are very delicate. And it's not just as simple as, meeting someone and liking each other. It's much more complex than that. And it's really about how the knowledge that you produce, particularly scientific knowledge that you produce, also filters down back to these farming communities and helps them make decisions on their farm. Is this a purely extractive empirical project where we're just going, studying them and publishing in our international journals and walking away? Or are we developing relationships with them where we share the results of our research? And hopefully we do research that is actually of value to these people as well. So there's kind of a couple of different dimensions to that. And it's difficult and it's complex. But yeah, I basically think it's the environmental future that's coming to us all, coming to a farm near you.
Maybe that's a good point. We do have some additional questions in the chat here, but I realized that we are also a little past time for those who were planning on being here for 60 minutes. So I will just thank you both for being here. And maybe as a follow-up, if folks in the chat wanted to put their email, we can grab that and follow up with a Talking Soil sort of email out to everyone who would be interested in asking some of these questions. I think there's some really good questions that are locally specific, some questions about gardeners in East New York, Brooklyn, questions about gardens outside of London. So maybe we can put folks on a thread, if you don't mind being on a thread with each other, and continue talking and thinking through soil asynchronously a little bit here, and use this as a kind of generative start that will hopefully grow some new soil-based relationships. Thank you both so much for joining us today, Brooke and Seth, and thank you everyone in the audience. It's really lovely to see people joining for their lunch hour here during NYC Climate Week. And we will continue putting on other webinars, so please follow us and check out our website at wright-ingraham.org. Also, you can join us in person if you are in Denver at the SER conference next week. We will be out there as well, so perhaps see some of you there in person. Thank you so much.